going to discuss today in this session what are the oxidations and reduction reactions. So basically, this is not a new words for you people, as you have already been educated with this terminology since the when you have started learning this chemistry, whether it is organic chemistry, inorganic chemistry, or physical chemistry, where you might have come across some cells, battery cells, which are essential for production of certain level of energies. Oxidation and reduction. Oxidation means what? Simply, we can call oxidation as the addition of oxygen. Reduction, we can call reduction as the removal of oxidation. एक जगह में oxidation is being added. At the other point, oxygen is. So this way, both the processes are opposite to each other. One is called addition of oxygen, other is called removal of oxygen. So that way, both the processes are different. Another way we can call oxidation in terms of oxidation number. You have already learned what is called oxidation number during your schooling, and you know that oxidation is increase in oxidation number for a particular metal or atomic center, right? So if there is an increase in oxidation number, let us say from 2 to 4 or 1 to 3, that is called oxidation, increase in oxidation number. Then another process is called reduction. Reduction means basically there will be reduction, there will be decrease in oxidation number. That is called reduction. Let us say if oxidation number is 3, then it may become 1. So this process is termed as reduction. If oxidation number is 5 and that becomes 2, that is also called as reduction. So oxidation and reduction can be defined according to the addition of oxygen, according to oxidation number. Third way we can also define, that is called hydrogen. In a certain reaction, if there is removal of hydrogen, that is termed as oxidation. Now I am defining oxidation with respect to the hydrogen gas, whether it is being added or whether it is being. Then another part is termed as reduction. So reduction is basically with respect to the hydrogen, that is termed as uh, removal of addition of hydrogen gas or addition of hydrogen. That is termed as reduction. ऑक्सीजन के हिसाब से भी we can also define oxidation reduction. Oxidation number के भी हिसाब से according to that, considering this, we can define this. We can also define oxidation and reductions according to hydrogen gas. If it is being added, so it is called reduction. You know, catalytic hydrogenation, when a carbon-carbon double bond containing compound is added with hydrogen gas, it will form alkane. So these reactions are also termed as, I mean to say, hydrogen. I mean to say reduction. Now, oxidation and reduction, these two processes are uh, different, but they always occur simultaneously, right? So now these reactions, which are called oxidation and reduction, they are termed as redox reaction. So यहाँ reduction से RAD and oxidation से if we take simply OX, then it will become redox. Okay, so that way these reactions are termed as redox reactions. Always, both the reactions occur simultaneously. Means, in a certain reaction, if some substance is being oxidized, parallelly, other substance is being reduced. So this is what called as oxidation and reduction reactions, redox reactions. ऐसा कभी नहीं होता कि oxidation is only there. There is no reduction. No, always there will be oxidation and reduction. So I was up to the definition of oxidation and reduction reactions, that we can define oxidation by addition of oxygen. We can also define the reaction in terms of oxidation number. We can also define the reaction in terms of addition of hydrogen or removal, as well as the same way. Fourth way, we can also define oxidation, that is electron addition, whether it is added or removed. Okay. So in a reaction, if oxygen is added, so sorry, in a certain reaction, if electron is added, then this is termed as reduction. Addition of electron is termed as reduction. And certain reaction where electron is removed, is liberated, or that is released, electron is released. So the release of electron is termed as oxidation. Okay, so there are total four ways we can define oxidation and reduction reactions. So this basically is more important. Okay, so friends, four ways we can define this oxidation and reduction. We need to if you understand the terms, it will not be difficult for you to memorize the things. Addition of electron is called reduction. Addition of oxygen is called oxidation. Addition of hydrogen is called as reduction. And increase in oxidation number is termed as oxidation. This way, this is much easier. You people have already learned the things, but just I am now asking you to recall these concepts which you have. Some of the reactions which are this way we can define. Look at to this definitions of oxidation. Addition of oxygen, removal of hydrogen, loss of electrons, increase in oxidation. These are the several examples. That if we have iron oxide, because I am teaching organic chemistry, and these are the examples of inorganic chemistry. So maybe you have, or you should visit also the same examples under the umbrella of inorganic chemistry. Okay. So another way, what is the one more sub terminology we should learn under this, that is termed as oxidizing agent. That is their oxidizing agent. In oxidation reaction, there will be always one oxidizing agent. तो ऑक्सीडाइजिंग एजेंट का काम होता है दूसरों को ऑक्सीडाइज करना, बट खुद का वो रिडक्शन होगा. Such as we have oxygen gas is one of the oxidizing agent. I can give some other examples such as hydrogen peroxides, which are oxidizing agents, and some other alkyl peroxides. They are also oxidizing agents. And you will have visited peroxides during your anti-Markovnikov addition, where peroxides can uh, create or can liberate these free radicals. This way, sometimes concentrated nitrate of benzotriazole is from our and nitrite. We can use that oxidizing agent. So this way, this process we can term. And similarly, the another substance which is apart from oxidizing agent, that is termed as reducing agents. There are varieties of reducing agents are available, which can perform reduction of other substance. Reduction, they basically perform for some different substance. खुद का oxidization is possible. So examples of the same are sodium borohydride, NaBH4. Some other examples such as sodium cyanoborohydride, NaCnBH3. Sodium cyanoborohydride that can be also used for this purpose. Borane is nothing but BH3. That is also, it can be used for reduction purpose. Hydrogen gas itself is a reducing agent, right? And this way, there are several reducing agents. Okay, so here this lithium aluminum hydride, that is one of another strong reducing agents and reduce the substance. So there is a beautiful chapter in this organic chemistry by Claydon, which is a good, very good book. I shall always suggest you to refer this, or else you can refer Organic Chemistry by P.Y. Bruce. That is also another good book where it's very nicely elaborated several oxidation and reduction. So my objective is to teach you people what are these oxidation and reduction reactions used in organic chemistry. Because in organic chemistry, you people might have visited several reactions, right? So there are thousands of reactions are there in inorganic chemistry. In organic chemistry, I would like to introduce you people with oxidation of certain substances. So one of the reaction of this is Bayer-Villiger reaction. Okay, so I'm going to present that reaction in front of you so that you people can educate yourself with this Bayer, what is called Bayer-Villiger. Okay. So Bayer-Villiger reaction, this is basically discovered by a scientist whose name is Bayer-Villiger. Two scientists are there. One of them is Bayer, other is Villiger. So these two people have developed the oxidation of organic compounds. So one of the title reaction is there on your slide, where we can convert this ketone into ester with the help of hydrogen peroxide. And simply hydrogen peroxide will be making in the form of ester. Okay, so I'm going to teach that reaction to you people with the help of this documentary, which is with me, so that you can learn what is called here oxidation reaction. On one hand side, we have ketone. So in the presence of hydrogen peroxide, such as this ketone over here, that is cyclopentanone. Presence of this hydrogen peroxide, it is converted into lactone, 6-member cyclic compound. Along with that, there will be formation of water. What is hydrogen peroxide? Hydrogen peroxide is like this, two oxygen atoms connected with each other. Okay? So one of the hydroxide will snatch the proton from hydrogen peroxide and it will make this anionic oxyanion plus water. Now it will, this oxyanion, basically peroxide anion, so that is going to act or react with carbonyl compound, and thus it will form this oxyanion. And I mean to say another highly stable, unstable molecule. Because this is the way where two hydrogen two oxygen molecules or atoms are connected with each other. And when this oxygen ka jo negative charge will be pulsed back, so then this methyl group will transfer from the carbon to the oxygen. And moment it is transferred from the carbon to oxygen, a rearrangement is possible. And this way we have ester, hydroxide anion, which will be regenerated. So this is the reaction mechanism for Bayer-Villiger reaction. Okay, so this is synthesis of, I mean to say, some compounds which are cyclic esters. So how the way this reaction is possible? This is basically nothing but when the negative charge come back from the oxygen, you can assume that there is a formation of this substance along with formation of, यहाँ पे दूसरी ओर से दिखा रहे हैं, it is carbon ion CH3 minus. Now CH3 minus can attack on this oxygen. It is connected with carbonyl carbon. Likewise this. And it can remove the hydroxide anion, and thus we can have formation of ester. Okay, so this reaction is termed as Bayer-Villiger oxidation. If you have acetone, you can convert the substance into methyl acetate. Likewise, this even we can use the this hydroxonium ion. There is a difference between both of this. If we react ketone with this hydronium ion of water, then it will form protonated carbonyl oxygen containing species, and thus it will promote the another substance to attack on this. Okay, so thus this way this some substance such as water or even hydrogen peroxide may attack on this carbonyl carbon. So previously we have seen that is basically base catalyzed Bayer-Villiger oxidation. This one is basically acid catalyzed Bayer-Villiger oxidation. Okay? So you can see in the reaction now there is a bond formation between oxygen and carbon. So now this proton shall be transferred from this peroxide oxygen other way, and the reaction is going to this. The role of water molecule is also that, so it will snatch the proton from the oxygen. Oxygen charge will be neutralized. So now we have this reactive species intermediate which contain 3 oxygen atoms. Fine. So now this is basically reversible reaction because वाटर ने H प्लस लेके खुद बन गया है हाइड्रोनियम आयन H3O plus. Now this water basically this is a process to promote the migration of methyl from carbonyl carbon to oxygen. So this way this reaction is there. And all the steps are basically to promote this migration of methyl group from carbonyl carbon to oxygen. When the oxygen lone pair which will be back, the first way this methyl will shift And this shift of methyl sometimes is also termed as a different way. You refer higher advanced organic chemistry. And this intermediate is termed as Tri-G intermediate, CRIGEE intermediate, Tri-G intermediate. And this, thus, it will form the ester. So you don't have to remember a lot about the reaction mechanism. If you feel that is much difficult, then don't worry. It's more if you simple remember what is the starting material, what is the product. However, this intermediate is totally unstable because it contains three electronegative oxygen atoms, in which two of the oxygen atoms are connected with each other. So this reaction is called as Baeyer-Villiger oxidation of ketone. If you have acyclic ketone, you will get acyclic ester. If you have cyclic ketone, then definitely you are going to get this, you can say, cyclolactone, cyclic lactone. This 5 membered आपका 4 membered रिंग है स्टार्टिंग मटेरियल, तो वो बन जाएगा 5 membered. 5 membered है तो आगे चल के वो बन जाएगा 6. So on this slide, they are trying to give you the account of how the migratory insertion is possible from carbon to oxygen. So here, the movement of electron is more important. You can see that previously it was attached to this oxygen, carbon, methyl group, which is red colored one, was attached to this carbon. Later on, it attached to oxygen. So this way, this is there, right? And slowly, it migrated from carbon and then it reached to oxygen. And then there was a breakdown with this when this water molecule is ready to leave. So at the first instance, this organic chemistry is always difficult. You will be feeling little boring. But if you make a practice with the help of your pen, paper, you will be able to learn much easily and much is also possible with the help of this trifluoro peroxy peroxy acid. जैसे we have hydrogen peroxide. If we replace the hydrogen with alkyl, it will become alkyl peroxide. And this is alcohol, basically peroxy acid. COOH, you know, COOH is carboxylic acid. But C double bond O, bond OH, that is termed as C double bond O and then further OH. So that is termed as peroxy acids, peroxy acid. This is trifluoro peroxy acetic acid. So that is also as can create such kind of Baeyer-Villiger oxidation. Basically पर्पज यही है कि यहाँ पे जो हाइड्रोजन है that is highly acidic. This acidic proton will be able to further protonate carbonyl oxygen and will make thus this reaction possible. तो ट्राइफ्लोरोएसीटेट का ऑक्सी एनाइन बन जाएगा और ट्राइफ्लोरोएसीटेट एंड ऑक्सी एनाइन oxide anion basically, that was this one, and which will attack on electropositive carbonyl carbon. So यहाँ पर भी similar kind of migration is possible when the oxygen का negative charge lone pair will be there. So that will move the methyl to migrate towards the oxygen, and once the methyl is migrated towards the oxygen, we shall have formation of methyl ester. This one and there will be formation of trifluoroacetate anion. And this trifluoroacetate anion will later on snatch the proton from this protonated carbonyl ester, will make trifluoroacetic acid. So trifluoroperoxyacetic acid at the end of the reaction is trifluoroacetic acid. Okay? And now we have this substance that is basically this one, methyl ester. So this reaction is called as methyl acetate बोलते हैं उसको, along with the formation of this trifluoroacetic acid. So trifluoroacetic acid is a byproduct. There is a popular reagent which is called MCPBA. In the form name of this MCPBA is metachloroperoxybenzoic acid. So this is also peroxy acid. Since it is metachlorobenzoic acid, so that's why it is termed as metachloroperoxybenzoic acid. Full form is MCPBA. And this is a substance which is used for the purpose of, again, same in Baeyer-Villiger oxidation. जैसे हमने ट्राइफ्लोरोएसिटिक एसिड का एग्जांपल देखा and then we have seen how it can catalyze the reaction. Similarly, this MCPBA also can convert this esters into this kind of reactions. So I hope that I'm able to explain you people regarding this reaction, what is called Baeyer-Villiger oxidation. And that is totally used for oxidation of ketone into ester. If you have ketone, you can convert into ester. If you have cyclic ketone, you can convert them into lactone. Although there is possibility of certain rearrangements, we have not discussed into this into this slides or documentary. Let us say if we have methyl and also on other hand side ethyl. So here there is certain formation of carbocation, and to stabilize that way, bulkier group will prefer to migrate. So ethyl ka migration is possible if you have 2-butanone instead of acetone. And sometimes the bulkiest group, tertiary butyl, is present on either of this carbonyl carbon, attached to either carbonyl carbon. So that will be preferred to undergo migration over any other substance. So this is actually higher advanced level of chemistry, not in your syllabus, but simply you have to remember this Baeyer-Villiger oxidation and the further hands-on. So with this, we shall be stopping up to this, and we will continue our discussions on coming class with the new oxidation reaction called as Swern oxidation. Okay, thank you.